Right now, this week, three completely separate stories are unfolding across our solar system, and each one on its own would be enough to rewrite a chapter of a textbook. A rocket booster humanity accidentally lost track of just slammed into the far side of the moon at more than 5,000 miles an hour, carving a brand new crater into a world we thought we already knew nearly everything about. 3 billion miles away, a spacecraft that flew past a tiny frozen world a full decade ago just handed scientists genuine proof that liquid is actively moving across a surface so cold it makes Antarctica feel like a warm summer beach by comparison. And on the planet next door, the one we spent decades writing off as a dead, crushed, sulfuric wasteland, researchers have found direct evidence that its volcanoes are erupting right now, in numbers that put it in the same club as Earth itself. 3 stories, 3 separate worlds, all breaking in the same short stretch of time, and every single one of them is forcing scientists to admit they didn't have the full picture. Stay with me here, because we're going through all 3 in order, with the actual science behind each one, not the exaggerated version currently spreading across social media. And if this kind of rapid-fire, real-sourced space coverage is genuinely what you come here for, go ahead and subscribe right now, because stories like these 3 are landing constantly, and you truly don't want to miss the next one. Let's start with the moon, because this is genuinely the story that happened most recently, and it happened almost exactly the way a small group of amateur astronomers said it would, months in advance. On January 15th of last year, SpaceX launched a Falcon 9 rocket carrying 2 commercial lunar landers, including Firefly Aerospace's Blue Ghost 1, as part of NASA's Commercial Lunar Payload Services program, an initiative designed to get private companies delivering scientific hardware to the moon's surface on a regular, affordable basis, using competitively awarded contracts, rather than NASA building and operating every lunar mission entirely on its own. The mission itself went fine. The landers deployed, the primary objectives were met, and in the ordinary run of things, the spent upper stage of that rocket, the second, smaller section that does the final push toward its target before its job is finished, should have simply drifted off into an unremarkable forgotten orbit around the sun, the way thousands of pieces of expended rocket hardware have done for decades, largely unnoticed and untracked by anyone outside a small community of dedicated observers. That's not what happened this time. According to NASA, solar activity and gravitational forces combined to nudge the stage's trajectory in a direction nobody had originally planned for, and it began an unplanned, slow-motion return toward the moon. Nobody at SpaceX ever commanded the stage to make that move. It simply happened, the product of the sun's radiation pressure and the subtle gravitational tug of the moon and Earth working on a piece of drifting metal over the better part of a year and a half, a reminder that even objects with no engine and no active guidance system remain subject to forces that can slowly, quietly redirect their path over long enough stretches of time. The person who first caught what was coming wasn't a NASA scientist or a SpaceX engineer. It was an amateur astronomer named Bill Gray, who has made something of a specialty out of tracking exactly this kind of abandoned space hardware using publicly available orbital data, and who has now correctly predicted a lunar impact from leftover rocket debris on more than one occasion, having previously identified a mystery rocket body that turned out to be a Chinese Long March booster years earlier. Gray flagged the trajectory, ran the numbers, and determined the Falcon 9 upper stage was on a collision course with the moon, a prediction that both NASA's Center for Near-Earth Object Studies and SpaceX itself independently confirmed once they started tracking the object more closely using their own separate observational data. On August 5th, 2026, at 2:35 in the morning Eastern Time, the roughly 45-foot upper stage, weighing somewhere around 10,000 pounds, struck the moon's far side near a large crater named after physicist Albert Einstein, traveling at approximately 5,400 miles an hour. Because the impact happened on the far side of the moon, the hemisphere permanently facing away from Earth, nobody on the ground could actually watch it happen in real time as it occurred. But researchers had spent weeks preparing for exactly this moment anyway, because even though you can't watch an impact you can't see, you can absolutely study what it leaves behind afterward. Before the impact even occurred, a team of researchers at the University of Texas at Austin, led by a scientist named William Joe, published a preprint paper modeling exactly what the resulting debris plume and impact site should look like, giving observers a genuine scientific framework to interpret whatever NASA's instruments eventually captured, work that involved calculating expected ejecta patterns, dust plume brightness, and the ideal viewing geometry for any telescope, hoping to catch even a brief flash at the moment of impact. NASA itself, working alongside SpaceX in the days leading up to the event, used both ground-based telescopes and space-based assets to track the stage's final approach, with the explicit goal of collecting lunar surface data from the impact and using the event to refine techniques for tracking objects in deep space more broadly. That refinement matters more than it might sound like at first, because tracking small, dark, tumbling pieces of metal against the blackness of space is genuinely difficult, and every real-world data point researchers get from an event like this helps improve the models used to predict where the next piece of drifting debris might end up. Models that will only become more important as lunar traffic increases in the years ahead. Scientists estimated the resulting crater would measure somewhere between 60 and 90 feet across and roughly 12 feet deep, based on the stage's mass and velocity at the moment of impact, and NASA's Lunar Reconnaissance Orbiter, which has been circling the moon since 2009, taking detailed images of its surface, is expected to eventually pass over the impact site and capture before and after imagery, a process that, based on similar past events, could take anywhere from several weeks to several months to complete. Simply because finding a crater this size scattered somewhere within a large search region takes careful, methodical comparison of thousands of images taken at slightly different angles and lighting conditions. It's worth being clear that nobody involved in tracking this event considered it dangerous in any way. NASA has noted that meteoroids carrying similar energy strike the moon naturally on a roughly 6-day cycle, meaning the moon is, in a very real sense, built to absorb exactly this kind of impact as a routine part of its existence, lacking the thick, protective atmosphere that burns up smaller objects before they ever reach Earth's surface. Harvard astrophysicist Jonathan McDowell, who has tracked orbital debris and spacecraft activity for decades, has described similar past lunar impacts from abandoned rocket hardware as interesting, but not, on their own, a huge deal, noting that abandoning spent stages in deep orbit has historically been standard practice across the entire space industry, not something unique to any one company or country. But the event does point towards something that's becoming a genuinely serious concern within the space industry, and it's worth spending a moment on before we move to the next story. Current estimates place the total mass of human-made debris scattered around and on the moon at more than 200 tons, a number that includes everything from entire abandoned rocket stages to discarded equipment left behind by crewed and robotic missions dating back to the earliest days of the space race, and that figure has been climbing steadily as more countries and private companies launch missions toward the lunar surface. As NASA's own planned lunar base moves forward, and as China and a growing number of commercial companies accelerate their own lunar ambitions, experts have warned that without meaningfully improved tracking systems and genuine international agreements governing how spacecraft get disposed of once their missions end, the moon faces a rising risk of collisions between future missions and this accumulating cloud of drifting debris, along with the very real possibility of accidentally contaminating or disturbing scientifically or historically significant sites, including locations tied to humanity's earliest crewed missions to the lunar surface. This particular impact was harmless and, from a research standpoint, genuinely useful, giving NASA a rare, precisely predicted opportunity to study exactly how an artificial object interacts with the lunar surface under known conditions. The next one might not be quite so convenient, especially as lunar traffic continues to increase over the coming decade. If you're finding the sheer amount of leftover hardware quietly drifting around up there as surprising as I did, drop a comment and let me know, because it genuinely shapes what we dig into next. Now, let's travel a great deal farther out, past Mars, past the asteroid belt, past Jupiter and Saturn and Uranus and Neptune, to a small, frozen world that most people still think of as the 9th planet, even though it officially lost that title back in 2006, when the International Astronomical Union voted to reclassify it as a dwarf planet instead, a decision that remains genuinely contentious within parts of the scientific community even today. Pluto sits so far from the sun that even at high noon, standing on its icy surface would feel closer to a deep twilight than genuine daylight. And its temperatures typically hover somewhere between roughly negative 387 and negative 369 degrees Fahrenheit, cold enough that nitrogen, the same gas that makes up most of the air currently filling your lungs, freezes completely solid the moment it touches Pluto's surface. For most of the 20th century, Pluto was treated as a geologically dead world, a frozen leftover with nothing dynamic left happening on it at all, an assumption that made a certain kind of sense given how little detailed information anyone actually had, since even the most powerful telescopes on Earth could only resolve Pluto as a tiny, blurry smudge of light for decades after its discovery in 1930. NASA's New Horizons spacecraft changed that assumption forever when it flew past Pluto in July of 2015, after a journey lasting nearly a decade across billions of miles of empty space, capturing the first close-up images humanity had ever seen of this distant world during a single, narrow flyby window, lasting only a matter of minutes before the spacecraft continued on into the darkness of the Kuiper Belt, never to return. What it sent back revealed a massive, pale, heart-shaped plain of nitrogen ice, mountains built from water ice hard enough to behave like solid rock, and layers of blue atmospheric haze rising hundreds of miles above the surface, visible even when backlit by the distant, dim sun. That heart-shaped feature is called Sputnik Planitia, a vast, frozen glacier of nitrogen ice larger than the American states of Texas and Oklahoma combined, and it has remained one of the single most studied regions of Pluto's surface in the decades since New Horizons captured it. Researchers immediately noticed something strange in the imagery from the glacier's northern edge. City-sized convection cells, essentially giant, slow-moving polygons formed as the nitrogen ice churns in cycles from underneath, separated by both thin, dark, linear features and more diffuse, cloudier, dark patches. At the time, scientists suspected these darker features might represent historical evidence of liquid having flowed across the surface at some point in the past, but confirming that suspicion required years of careful, patient follow-up analysis, working from a single dataset that would never be refreshed or supplemented by any new spacecraft visit. That analysis finally came together this month. A new study published on July 31st, 2026 in the Planetary Science Journal and led by Alan Stern, the principal investigator of the New Horizons mission itself, brought together experts in Pluto's specific chemistry alongside researchers who specialize in terrestrial glaciology, the study of how glaciers behave and evolve here on Earth, to take a fresh comparative look at that decade-old imagery. Their conclusion, revealed just this week, is that these dark, linear, and diffuse features on the northern edge of Sputnik Planitia have likely been occasionally and temporarily wetted by an actual liquid, most probably liquid nitrogen, seeping up from beneath the glacier's surface. Researchers reached this conclusion by directly comparing the darkened patterns on Pluto's glacier to features seen on terrestrial glaciers here on Earth, specifically the kind of darkening that happens when glacial ice gets wetted either by rainfall or by liquid emerging from underneath through a process called basal melting. But here's the detail that makes Pluto's version of this process so strange and so genuinely significant. On Earth, that kind of wetting almost always comes from rain falling from above. On Pluto, given the planet's specific atmospheric and thermal conditions, liquid nitrogen rain is considered physically impossible under any known model of the planet's climate. That leaves only one plausible explanation for what researchers are seeing, that this liquid nitrogen isn't falling from Pluto's thin atmosphere at all. It's rising up from underneath the glacier, seeping through cracks and reaching the surface from below in a process that mirrors basal melting on Earth, but is being driven by whatever heat source exists deep within Pluto's frozen interior. Alan Stern himself, discussing the discovery, put it about as plainly as a scientist of his standing tends to put things, saying that Pluto never stops surprising the researchers who study it, and that beyond simply suggesting liquids have recently expressed themselves on the surface, this result points toward an entirely new kind of time variable feature on Pluto, meaning parts of this distant world's surface are actively changing, wetting and drying, on timescales short enough for a single spacecraft's brief flyby imagery to have actually caught the process in motion, a possibility almost nobody would have seriously entertained before New Horizons ever reached the outer solar system. This finding connects directly to a broader, years-long scientific debate about whether Pluto might be hiding something even more significant beneath its frozen crust, an actual subsurface ocean of liquid water. Researchers at Washington University and St. Louis and the Lunar and Planetary Institute have spent years building mathematical models suggesting that a liquid water ocean, buried somewhere between 25 and 50 miles beneath Pluto's icy shell, could plausibly still exist today, kept from freezing solid entirely by a combination of residual internal heat and the insulating effect of the ice sitting above it. The evidence supporting this idea isn't a direct photograph, because no instrument has ever looked beneath Pluto's surface. It's a pattern, cracks, and ridges across the surface that line up in ways consistent with a layer of liquid, shifting slowly underneath, combined with the fact that Pluto lacks the kind of equatorial bulge you'd expect to see if its interior had frozen completely solid and rigid long ago. Perhaps the most compelling piece of that broader ocean puzzle comes from a pair of massive, isolated mountains south of Sputnik Planitia, one standing roughly 13,000 feet tall and the other reaching closer to 20,000 feet, with a base wide enough to rival some of the largest volcanoes here on Earth, both featuring deep depressions at their summits and lumpy, uneven flanks that closely resemble cooled lava flows here on Earth, except Pluto has no molten rock anywhere in its makeup. If these features are what researchers increasingly believe they are, they're cryovolcanoes, structures that once erupted not with liquid stone, but with a thick, slushy mixture of water, ammonia, and methane forced upward from somewhere deep beneath Pluto's icy crust. The area surrounding these particular peaks notably lacks the impact craters scattered across most of the rest of Pluto's surface, suggesting this network of ice volcanoes was active as recently as somewhere between 100 and 200 million years ago, a time frame that is genuinely recent by the standards of solar system geology, and researchers analyzing the surrounding terrain have suggested the entire network of cryovolcanoes may draw from a single, shared liquid reservoir somewhere beneath the surface, rather than each structure venting independently. Put all of that together, the newly confirmed liquid nitrogen wetting events, the cryovolcanoes, the cracked and shifting surface patterns, and you get a picture of a world that is nowhere close to the inert, frozen relic it was assumed to be for most of the 20th century. Pluto, it increasingly appears, still has active internal heat, actively moving liquid, and a surface that is genuinely still changing right now in ways New Horizons only caught the faintest hints of during its brief, single pass a decade ago. Hints that researchers are still working through today using nothing more than the imagery that single flyby left behind. If that shift in how we understand Pluto is landing the way it should, hit the like button on this video right now, because it genuinely helps stories built on real published research like this one reach more people instead of the louder, less accurate versions that tend to spread faster online. Now let's bring this back much closer to home, to the planet that sits directly next door to Earth, and that for most of modern astronomy's history has been treated as a cautionary tale rather than a place of active geology. Venus is almost exactly the same size as Earth, similar in mass, similar in bulk composition, close enough in so many fundamental ways that scientists have long called it Earth's twin, a comparison that only makes its current condition feel stranger the more you sit with it. And yet its surface conditions are almost impossible to overstate in their hostility. A crushing atmospheric pressure roughly 90 times what we experience at sea level here on Earth, equivalent to the pressure found nearly a kilometer beneath the ocean's surface, a thick, permanent blanket of clouds made from sulfuric acid, and surface temperatures hot enough to melt lead, hovering around 860 degrees Fahrenheit thanks to a runaway greenhouse effect that trapped the planet's heat billions of years ago and never let go, turning what may have once been a far more temperate, even potentially habitable world into the hottest planetary surface anywhere in our solar system. Hotter even than Mercury, despite Venus sitting considerably farther from the Sun. For decades, the dominant scientific assumption was that Venus, whatever active geology it once had long since gone cold, and still, its crust locked in place as a single unmoving shell with no active volcanoes, no shifting plates, nothing resembling the dynamic living planet, sitting one orbit closer to the Sun. That assumption has been collapsing piece by piece for the last several years, and the tool doing most of the collapsing is, strangely enough, a spacecraft that stopped operating more than 3 decades ago. NASA's Magellan spacecraft, released into Earth orbit by the Space Shuttle Atlantis in May of 1989 before making its own way to Venus, orbited the planet from 1990 to 1992, using radar to see straight through the planet's thick cloud cover and map, roughly 98% of its surface in detail that, remarkably, has still never been fully surpassed by any mission since, a genuinely striking fact given how much spacecraft technology has advanced in the more than 3 decades since Magellan's mission ended. For decades, that Magellan data simply sat in archives, studied and restudied for broad geological features, but never specifically combed through for evidence of change over time, because nobody had a strong enough reason to believe such change would actually be there to find, and because comparing 2 separate radar passes of the same terrain, looking for subtle differences buried in enormous volumes of low-resolution data, is exactly the kind of painstaking, unglamorous work that tends to sit low on any research team's priority list until someone finally decides to take a chance on it. That changed in 2023, when researchers Robert Herrick and Scott Hensley took a fresh, painstaking look at 2 separate Magellan radar passes over the same stretch of terrain near the volcano Mat Mons, taken about 8 months apart, and found that a volcanic vent's circular mouth, its caldera, had visibly grown and changed shape between the 2 images, consistent with a caldera collapse caused by magma draining away beneath it, the same basic process that occurred during a well-documented 2018 eruption at Hawaii's Kilauea volcano here on Earth. It was, at the time, the first direct geological evidence of an active volcanic eruption ever captured on Venus, instantly making it only the 3rd body in our entire solar system, alongside Earth and Jupiter's fiery moon Io, confirmed to host active magma volcanism, a genuinely exclusive club that Venus had spent decades being excluded from entirely. Robert Herrick himself, discussing what that discovery meant, put it in blunt, memorable terms, saying researchers could now rule out the idea that Venus is a dying planet. The discovery was published in the journal Science and presented at the Lunar and Planetary Science Conference, and researchers involved noted it also meant future missions to Venus would eventually be able to study genuinely fresh rock material, offering a direct sample of the planet's interior chemistry rather than relying entirely on surface material that could be billions of years old. And then, in 2024, a separate team of Italian researchers went back through that same archive of decades-old Magellan images, conducting what amounted to a massive, painstaking search across a planet that has 3 times as much dry land area as Earth does, hunting specifically for any other signs of surface change that earlier researchers might have overlooked in the sheer volume of available radar data. Their search paid off. At two entirely different locations, the western slopes of a large shield volcano called Sif Mons and a flat vent-studded plain called Niobe Planitia, they found long, winding, snake-like features that appeared in one Magellan radar pass and were absent or meaningfully different in another pass of the same terrain. The researchers initially considered whether these features might simply be landslides rather than lava flows, a more mundane explanation that wouldn't require any volcanic activity at all, but the locations argued against that interpretation. Both sites sat on relatively flat terrain, exactly the kind of ground where landslides of this scale wouldn't ordinarily be expected to occur, while the way these features spilled and spread across the landscape matched the behavior of flowing lava far more convincingly. The team published their findings in the peer-reviewed journal Nature Astronomy in 2024, concluding that volcanism on Venus is not just historically present, but genuinely ongoing, active, during the very years Magellan happened to be orbiting overhead. Paul Byrne, a planetary scientist at Washington University in St. Louis, who was not directly involved in that particular study, described the discovery as another meaningful step toward understanding Venus as what he called a living, breathing world, a description that would have sounded almost absurd to most planetary scientists working just a decade earlier, back when the prevailing textbook consensus still leaned heavily toward a cold, geologically frozen interpretation of the planet. And Byrne made a point worth sitting with for a moment, noting that Magellan's radar resolution was relatively low, and Venus's surface area is so enormous that finding even these few confirmed signs of active volcanism required genuinely painstaking, needle-in-a-haystack effort spread across a search area larger than all of Earth's continents combined. If a dedicated team of researchers spent years combing through the entire surface specifically looking for this kind of evidence, Byrne suggested, there's likely far more activity out there simply waiting to be found. Both Byrne and the study's own authors now believe Venus could currently host volcanic activity on a scale comparable to Earth itself, a genuinely startling reversal from the geologically dead depiction that dominated textbooks for most of the last 50 years. That belief has only gained further support from newer research completed just weeks ago, in July of 2026, when a team led by researcher Taras Garia built detailed computer simulations of Venus's interior and found that the planet's surface appears to be actively tearing itself apart from within, forming wide, elevated rift structures that closely match features already visible in that same archival Magellan imagery, strengthening the broader case that at least some of Venus's rifts and volcanic terrain formed relatively recently, and that the planet's interior remains considerably more dynamic than scientists assumed for the majority of the space age. None of this current evidence would have been possible without spacecraft data that is, in some cases, more than 3 decades old, which says something important about how much value still remains locked away in archives from missions that ended long ago, waiting for the right question or the right comparison to finally unlock it. But researchers aren't planning to rely on decades-old radar forever. NASA's upcoming Veritas mission and the European Space Agency's Envision mission are both being specifically designed to map Venus's surface in far greater detail than Magellan ever could, equipped with instruments built from the ground up to detect exactly this kind of subtle surface change over time, rather than requiring researchers to comb painstakingly through old, lower-resolution archival data, hoping to spot something a previous generation of scientists happened to miss. Veritas in particular is expected to carry a next-generation synthetic aperture radar system capable of producing images with resolution far exceeding anything Magellan's 1980s-era hardware could achieve, alongside a spectrometer designed to help identify the specific chemical composition of any freshly exposed rock, information that could help researchers distinguish genuinely new lava flows from older, previously mapped terrain almost immediately, rather than requiring years of comparative analysis after the fact. Once those missions reach Venus in the years ahead, scientists expect the current handful of confirmed active volcanic sites to grow substantially, transforming Venus from a planet where active volcanism was recently found almost by accident into one where it's tracked, mapped, and studied as a routine, ongoing planetary process, the same way volcanic activity is studied here on Earth, with dedicated monitoring networks and regularly updated maps of where the next eruption is most likely to occur. So here's where all 3 of these stories actually connect, and it's worth sitting with for a moment before we wrap up. A rocket humanity built and then simply lost track of just proved, in the most literal way possible, that the space surrounding our own planet and the surface of our nearest neighbor is more cluttered and less carefully managed than most people realize. A quiet, accumulating problem that rarely makes headlines until a specific, trackable object happens to come down somewhere researchers can actually study. A spacecraft that flew past a distant, supposedly dead world a full decade ago, and that will never fly past it again, just revealed that world is still actively changing today, wetting and shifting in ways nobody expected to still be happening, Proof that a single brief flyby a decade in the past can still yield genuinely new discoveries when researchers take the time to look at old data with fresh eyes and the right comparative tools. And a planet written off as geologically finished for the better part of half a century just proved, using nothing but old radar images sitting quietly in an archive since the early 1990s, that it may be erupting just as often as our own. A reversal so complete that the phrase geologically dead, applied to Venus, is quickly becoming a piece of outdated science rather than an accepted fact. 3 worlds, 3 timelines, and in every single case, the honest answer scientists are giving right now is that they simply didn't have the complete picture until very recently. And in 2 of these 3 stories, the missing piece wasn't even new data at all. It was old data, sitting patiently in an archive, waiting for someone to ask the right question of it. That's a detail worth remembering the next time a headline claims some corner of the solar system has been fully explored and finished. Because Pluto's decade-old imagery and Venus's 3-decade-old radar maps both just proved that assumption wrong within the same handful of months. If this kind of rapid, sourced roundup of what's actually happening across our solar system is what you come here for, subscribing and turning on notifications means you'll be here for the next one, because between lunar debris, outer solar system chemistry, and a planet quietly rewriting its own reputation, there is clearly no shortage of stories still unfolding, and new ones are turning up in old archives just as often as they're turning up in brand new observations. Drop a comment letting me know which of these 3 surprised you the most, whether it's the sheer scale of debris still drifting around our own moon, liquid nitrogen finding its way to Pluto's surface from somewhere deep underground, or Venus turning out to be far more alive than anyone gave it credit for. And if someone in your life still thinks of the moon as untouched, Pluto as frozen and finished, or Venus as a dead, crushed wasteland with nothing left to discover, share this with them, because as of this week, every single one of those old assumptions just took a direct hit, and the researchers behind all 3 discoveries are already looking for what comes next.